Okay, now we're section 5.1, logarithms and differentiation. That's already been written because, again, with this new tablet, I'm having some issues here and there, hitting things, and I don't know. We'll keep working at it. Oh, I did it again. Not sure. Oh, that's, So there's a little button that gets rid of everything. I need to, I guess, hold my hand so I can't hit it as easily. Still may hit it. But anyway, here we go. Logarithms and differentiation. So, for instance, suppose you'd like, you've got a function f of x that is the square root of x plus 1, and you want to find its derivative. Now, for us, it's not really that big a deal. We would, write it this way, and then if we wanted f prime of x, we would bring down the 1/2 and x plus 1 to the negative 1/2, like that. And then we could write it, I guess, as 1/2 times the square root of x plus 1. Okay, so, for us, with our ability to work with symbols and so forth, it's gotten pretty good. But, if instead I were to look at, say a function g of x equal the natural log of the square root of x plus 1, then that's the same thing as natural log of x plus 1 to the 1/2, which by properties of logarithms is 1/2 the natural log of x plus 1. And so, here, what I know is that then g prime of x is, just by looking at this piece over here, it's just 1/2 times 1/x plus 1 times the derivative of x plus 1, which is just 1. Okay, true. But also, you see I had g prime of x is equal to the natural log of f of x. And so, g of x is the natural log of f of x. So g prime of x is 1/f of x times f prime of x. And so, then what I see is that f prime of x is just g prime of x times f of x. Ah, pretty nifty. And so I could get f prime of x is just 1/2 times the 1/x plus 1 times the square root of x plus 1. Oops, hit that button again, x plus 1. But then with my algebra, I know that this is just 1/2 times the square root of x plus 1. Same answer. Okay, so if we look back up here, right, there was our answer, and there's our answer. Okay, so by, with these properties of logarithms, I can get at derivatives slightly different ways. And here, I don't know that it gained me a whole lot. But what's really nice is using this idea there, from this relationship, right, is that if I want to get at the derivative of this function inside the logarithm, actually I can take the logarithm of that function, take the derivative that way, g prime, and then just multiply by f of x, and I can get that derivative. So another example the textbook uses for this is they have an f of x equal, and I'm doing it a little bit differently than them, in that they just start with the logarithm. And so we have f of x is x times the quantity x squared plus 1 squared over the square root of 2x cubed minus 1. There we go. Okay, but now if I define g of x equal the natural log of f of x, okay, that's the natural log of that whole big mess, x times x squared plus 1 squared over the square root of 2x cubed minus 1, like that. But that, using properties of logarithms, okay, I have a product and a quotient, so that's, I've got the natural log of x plus the natural log of x squared plus 1 squared, and then minus the natural log of 2x cubed minus 1 to the 1/2. So this is the natural log of x plus 2 times natural log of x squared plus 1. Now we're stuck with the x squared plus 1. There is no way to break up a sum inside a natural logarithm. And then the same thing here, we'll get minus 1/2 natural log of 2x cubed minus 1. But then we're done there. We're stuck. Okay, but now see, if I take the derivative of g prime of x, that, well, that's 1 over x plus 2 over x squared plus 1. Again, just the derivative of natural log is 1 over, and then times the derivative of x squared plus 1 with respect to x, and then minus 1 over 2 times 2x cubed minus 1 times the derivative of 2x cubed minus 1 with respect to x. And that is 1 over x plus 2. Now, up here, the derivative x squared plus 1 is 2x, so 2 times 2x over x squared plus 1 minus, and the derivative of the 2x cubed minus 1 is 6x squared. 6x squared over 2 times 2x cubed minus 1. And I can simplify that a little bit with 1 over x. We've got 2 times 2 there, so that's 4. So 4x over x squared plus 1. And then minus, and I've got a 6 over 2, so that's makes 3x squared over 2x cubed minus 1. So that's the derivative of g prime. But now, to get the derivative of f, remember, we just have this relationship. F prime is g prime times f. Okay, so f prime of x is equal to g prime of x times f of x. And so g prime, well, that's that stuff. So I have 1 over x plus 4x over x squared plus 1 minus 3x squared over 2x cubed minus 1. And then all times f, well, let's see, what the heck was f? X times x squared plus 1 squared. So I've got x times x squared plus 1 squared over the square root, and that was the 2x cubed minus 1. So there you go. Now I could multiply through and get do some cancellation and so forth, but this will work. I mean, this thing right here is my derivative of f, and there was, in some ways there was quite a bit of work to do here, but all in all, I think it's a whole lot easier than dealing with a product rule and a quotient rule and then some chain rules in the mix of all that. Here, we still needed the chain rule up here, but a lot of the chain rule in the end was just that natural log of something. So it was 1 over, 1 over my function and then times that function's derivative, and 1 over that function again and times that function's derivative. So, this is really a nice way to go, is using a logarithm on something to do the derivative. And we'll do another video called logarithmic differentiation here to look at that a little more.